All right, so bell work day 9. Cameron forgot his 3-number locker combination. He knows the lock has numbers 0 through 29 on it. He also remembers the first number is either a 5 or a 15. The second number is odd, and the third number is 22. How many possible combinations are there? Who wants to offer up an answer? Hang on a minute.
Pardon the interruption. At this time, all AP Environmental Science students need to be released to the main gym. All AP Environmental Science students need to be released to the main gym. This afternoon, AP Psychology students need to report to the main gym by 11:30. AP Psychology students need to report to the main gym by 11:30. Thank you.
All right, Alex, what'd you get? 30. Anybody else? I don't know if that's right. I don't have my cheat sheet up here at all, which I will. All right, let's check it out. How many number lock combination is it? 3. So I need 3 horizontal lines to consider, okay? The first number is 5 or 15. Micah, how many options does it give me? If the first number is 5 or 15?
5.
What?
5.
5? I don't think I have 5 numbers there.
For the first one?
Yeah.
Oh, 30.
No. I have 30 numbers to choose from, but the first number is either a 5 or a 15.
15.
No. Somebody want to help him out? If you have 5 or 15, how many numbers is that? 2. Yeah, so there's only 2 options there. It's either going to be a 5 or a 15. Does that make sense? Because those are the only 2 we have. The second number is odd. Second number is odd. Kevin. If the second number is odd and I have 30 numbers total to choose from, how many would that be? Yeah, good job. So everybody see how he got that? He took 30. Because we have 30 total numbers from 0 to 29. And he divided it by 2 because every other number is going to be odd or even. So your odd or even numbers are always the total numbers divided by 2, or half. And the last number is 22. Well, how many different options is that then? How many different numbers is that? 1. Yeah. So 2 times 15 times 1 is 30. So the correct answer is 30. Nice job, Alex. Okay. All right, number 2. You are reaching into a box of 8 markers. The 8 markers have a yellow, a blue, a black, green, red, orange, purple, and brown. What is the probability you pick a brown or, gosh, why do I read that backwards? A black or a brown marker? What's the probability that I pick a black or brown marker? Well, if I were to write it out, it's going to look like this. A black marker, or is that the U or the upside down U? When I have an or statement. No, that's the U. This is the or statement. Black marker or a brown marker. Okay, remember that is the probability of a black marker plus the probability of the brown marker minus the probability of getting a black and brown marker at the same time. All right, what's the probability of picking out a black marker? 1 out of 8?
1 out of 10.
1 out of 10? There's only 8 markers, I think.
Well, I counted the black and brown marker.
1, 2, 3, 4, 5, 6, 7, 8. I think there's 8. Plus the probability of picking out the brown marker. What's the probability of picking the brown marker? 1 out of 8, right? Minus, do we have a black and brown marker at the same time? No, so that's 0. So 1/8 plus 1/8 is 2/8. Or if you want to reduce it, 1/4. I'm having a total brain fart. Okay. Is that right? That is right, isn't it? Let me go check my cheat sheet. I'm like, we multiply all the time. Are you sure you're adding here, Thede? Oh, I'm telling you, getting old. Pretty sure that's right. Let me check. On a day where I wasn't so out of it. Yep, it is. 1/8 plus 1/8 minus 0 is 2/8 or 1/4. Yeah. Creating them? I do the answers, yeah. Making sure, yeah. All right. Any questions on 1 or 2? Jeremiah, are you with us?
Yeah.
And your wonderful hair?
Yeah.
Everybody take a look at him right now where his head's down. He's got new, oh, we gonna see the braids. Everybody look now. Very nice. All right, so we're talking about conditional probability today. Conditional. Okay. We had compound yesterday. Compound probability talked about looking at 2 or more independent events at the same time. Today, it's conditional. Okay, and let's see. I think we're on page... Not there. Looks like 16 for you guys. Bottom of page 16. And do you remember how we said your denominator when it comes to probability is always going to be the total, except when you have a given that statement? Today's the day. So you really need to pay attention today. Okay? All right, so conditional probability. It's kind of like there's probability with a but. But this, okay? So a probability is conditional. A probability is conditional. This is page 16. Or dependent. So it is dependent on the occurrence of another event. So a probability is conditional or dependent on the occurrence of another event. Bjorn. Okay. The key here is it is dependent on another event. Okay. All right. So it says, let's translate this statement. Okay. So we want to say what is the probability of, how did I put? Okay, what is the probability of someone being over 6 feet tall? And then here is this word or this phrase that we say, given that they are on the basketball team. Okay. So this little perpendicular line right here in probability means given that. Okay. It means that the first part is dependent on this second part. So this second part is always going to be your denominator in a given that statement. Okay? So we want to know what's the probability of someone being 6 foot tall given that they're on the basketball team. So the people that are on the basketball team, the number on the basketball team becomes my new denominator. And then I'm going to look to see where do I have that intersection of people that are over 6 feet tall and on the basketball team. Okay? What? I'm sorry? Okay. So again, the second part, after that, given that statement, following that vertical line, is going to be your new denominator. All right, let's go to number 3. It says, what is the difference between the following statements? Okay. So the first one says, find the probability of a red car given that how do I want to say that? It is a 2-door vehicle. Okay. So that's this one. Find the probability of, should be of a red car, not on. Find the probability of a red car given that it's a 2-door vehicle. So if you are going to the car dealership, where are you going to look first? You're looking first at the 2-door vehicles. That's your denominator. Okay, that's the bottom part. And once you are in the section of all the 2-door vehicles, and I doubt that dealerships are like that, then you're going to look at all the 2-door vehicles and say, okay, how many out of the 2 doors are the color red? Okay? Whereas this other one says, find the probability of a 2-door vehicle given that, there's that given that vertical line, given that it is a red is a red car. So over here, in this case, you go to the dealership, and I know they don't have them like this, but if they did, they would say, all the red cars are right here for you, Miss Thede. Hang on just a minute. All the red cars are right here, and then I would look at all the red cars, and then I would try to find the 2 doors out of all the red cars. Yes?
Well, you guys like to ship, they say they have the Camaros, like they're a 2-door.
Right.
But I see what your point is, though.
Yeah. The difference is you look at the given that statement, and after that vertical line, just like you have a vertical line in your probability, well, it's not vertical. Sorry. It's horizontal most of the time. But this given that statement, whatever follows here is what goes in the bottom part of your denominator. Okay? Whatever follows here after the given that goes here in your denominator. Does that make sense? Just say yes, it's quicker. Yes. All right. So this might be a little bit confusing, but it says, what is the general calculation for conditional probability? It looks like this. Okay. It says that the probability of A given that B, remember this means given that, you actually say given that. Some people just say given, but I like given that, is equal to the probability of A and B all divided by B. Okay? So I told you, let me do this over again, that this B, whatever follows the given that statement, becomes your new denominator. Okay? And then the numerator is going to be the intersection of those two. All right? So let's just do a couple of these when we're looking at a table. So everybody ready to look at the table? Okay. It says college students were asked their favorite extracurricular activities. Everybody know what extracurricular means outside of general school? Between dance, sports, and film. So this first one says, what is the probability of choosing a woman given that they are in dance? What's the probability of choosing a woman given that they are in dance? Okay? Here's that given that. Given that. So, dance here is going to be my denominator. Dance is the denominator. How many total people do I have in dance? 18. So that's going to be your new denominator. Now, what is the probability of selecting a woman, given that we're looking at dance? So you've got dance, and then you find where the women are, and where they intersect, those are the women who are in dance. So that is going to be 16. Or another way to think of it is the probability of women and dance. Remember, that's the or statement. It's the intersection over dance. That's what it would be. Any questions on that? And we don't need to reduce it. We could, but we don't need to. All right, let's look at the one to the right. So that's the probability of selecting someone who likes movies given that they are a man. Okay? So that's the probability of movies or a man all divided by the number of men we have. That's what it means. Movies, given that they're a man. All right, so let's find our men. You go to the total. That's 20. Find where movies and the men intersect. 8. So the probability of selecting someone who likes the movies, given that they're a man, is 8 out of 20. Okay. All right. Now, I am going to see if I can stop writing that other little probability. What do you think would it be the probability of selecting someone who likes to dance given that they are a woman? First of all, tell me, what's my denominator going to be? Yes, 30. Because this is the women. Okay, and here's your given that statement. So the women go on the bottom, and then you look at intersection of dance and women. What's the intersection of dance and women? 16. Dance and women at the same time. Dance and women. All right, Jeremiah. All right, probability of choosing a man given that they enjoy sports as an extracurricular activity. All right, so Jason, what is my denominator going to be? Say it. No. Probability of selecting a man given that they're in sports. Here's my sports. Yeah. So you have to look at the sports. The sports is going to become your new denominator whenever you have that given that. All right. Now look at where men and sports intersect. Here's my sports. Here's my men and sports. And that is going to be, anyone? 10. This is men and sports. Okay. What questions do you have about those 4? It is really important for you to understand this with this given that statement. No questions? All right. Let's see if we can do just a little bit. Well, how much time do we have? How many do I have? Is there 4 left or just 2? Is it just 2? It is, isn't it? Okay, we'll finish these 2. All right. What is the probability? And I'm going to erase some of this because it's hard to see when you look up here now. What is the probability of selecting someone who does not prefer dance? Who does not prefer dance? Now, is that a given that statement? No. So what's my denominator going to be, Renisha? I saw you shake your head right away. You're right. It's not a given that statement. So I need to put that over what denominator? What denominator do we always put them over if it's a regular table?
100.
No. 50, the total right here, okay? So I know I'm putting it over 50. Does that make sense now? Because it's in that bottom right corner, all right? So that if it's a probability, it's always going to be over that bottom right corner if you've got the total, unless it's a given that statement. So the probability that someone did not select dance, there's a couple ways you can do that. Does anybody want to offer it up? Starla, what'd you get for an answer? Did you get an answer? 32. That is correct. So she said if they don't like dance, that means I need to look at sports and movies. Well, sports, that's 16 for the total, and movies is 16. Add those together, and that gives us 32. The other way to do it is to say 1, which is the full probability, minus those who like to dance. And that would be 50 over 50. That's another way of saying 1, minus 18 over 50. And that also would give you 32 over 50. So that's the second way of doing it. All right, last one. What's the probability of selecting those who like to do dance for extracurricular activities and those who are men? What's the probability of selecting those who like dance and those who are men? What's my denominator going to be? Daniel. What's my denominator going to be for this last problem?
50.
Very good. It is not a given that statement. So it's going to be over 50. And find dance and men where they intersect. 2. This is dance and men. So that's an intersection, which is 2. Okay. Any questions on those last 2? All right. Hey, let's take a look. Shoot, I don't think I brought that up. That's all the notes that I have for today. Any question on anything about conditional? Remember, conditional, it is dependent on other factors. It's dependent on whatever the total is that you're looking at, which is a new total, not the total. All right, let's take a look. You guys are supposed to be working on homework 7, I can't remember, 7-3. 7-3. Has anybody started 7-3 yet? No one started 7-3. Let me see if I can bring it up and see if we can get started on this. So I'm going to bring this up on my desktop. Well, if I can find it. Previous. Build. Preview. Okay. And let me go remote desktop. And what does this do? All right, so you should see it on the front board. This is homework number 3. Everybody, you should get this out. Let's do some of these together. Number 1 says if you are playing Yahtzee and rolling 2 6-sided dice at the same time, What's the probability that they both land on 6? Okay, you've got 2 dice. So I'm going to give 2 lines here. What's the probability that the first one lands on a 6? Guys, come on. Everybody look forward. You're rolling 2 dice. What's the probability that the first one comes out to be a 6? 1 out of 6. And does that affect the second one at all? No. So this is an independent event. What's the probability that the second one happens to roll a 6? 1 out of 6. When you multiply numerators times numerators and denominators times denominators. So 1 times 1 gives you 1. And 6 times 6 on the bottom gives you 36. On your calculators, that is 1 divided by 36. And what do you get for an answer? You have the calculators.
1 divided by 36. 0.027 repeating. It says write your answer as a decimal rounded to 3 decimal places. So I'm looking at this 7. Is that going to go up or stay the same? It will go up. So my answer is 0.028. 0.028. That is your first answer. Okay. All right, let me see if I can pull this down. Ooh, that's going to be messy. That's all right. I'll erase and we'll go. All right, let's see if we can get these next 2. All right, so we've got a table that shows endangered animals and threatened animals. It says for number 2, calculate the probability of selecting a bird. Is that a given, that statement? Has it got that vertical line in it? It does not. So what's going to be my denominator? Leilani, what's going to be my denominator for number 2? Can you see it? No. What's the denominator always going to be? Ranisha, what's my denominator going to be for number 2? Yes. Very good. 475. Now, we want to find the probability of selecting a bird. So look at your birds. Now, Leilani, what's my numerator going to be for the birds? There you go. Right. So it's 90 total birds out of 475. 90 out of 475. Any questions on number 2? All right, let's take a look at number 3. First of all, is that an and statement? Calculate the probability of amphibians and threatened, or is that an or? It looks like the N, right? Is anybody out there? Come on, guys. And, yes, it's an and statement, which means it's going to be an intersection. Intersection. Who haven't I talked to? Taryn. Number 3, what's going to be my denominator? Number 3, what's going to be my denominator? Oh, that didn't get any bigger. It got bigger on mine. All right, somebody help her out. Who haven't I talked to? Genesis, what's my denominator for number 3? No, denominator's the bottom number. No. My denominator, it's always going to be the total unless you have a given that statement. Ranisha, I'm coming back to you. What's my denominator? 475. Very good. All right. So, amphibians and threatened. Amphibians are right here. Threatened are right here. What is the probability of selecting an amphibian and threatened? What's my numerator? Anybody? Anyone? 7. All right. So there, you got the first 3 problems of this homework assignment. Okay? All right. Well, let's see what they've got for the announcements today. You can work on most of 7-3 now. And remember, you get 5 chances to do that. 5 chances. All right. Let's see what we got.
Good morning, students and staff. Today is Tuesday, May 2nd. I'm Mark, and these are your morning announcements. Yesterday was Senior Signing Day. We had a chance to catch up with some of the seniors.
Hello and welcome to RDTV. Today we have 3 of our lovely seniors that are graduating, class of 2023. They're going to give you their names, where they're going to school, and most importantly, what is the most memorable moment that they had here at PHS.
My name is Essence Eaton. Hi, my name is Brianna Armstrong. I'm going to Ball State. I'm going to Ivy State. I'm majoring in music production, and I will be majoring in business administration.
Business, entrepreneurship.
Hanging out with friends is my favorite senior memory. Oh, and show choir.
And my favorite high school memory had to be prom.
Get on my office.
Enjoy, class of 2023.
Attention all juniors, college playing night is May 9th at 5:30 p.m. in the Pike High School main cafeteria. Here tips on paying for college wisely and discuss topics such as choosing the right major or career, maximizing free money like scholarships and grants to financial aid process, comparing college costs, and more. And now it's time for Book Trader Tuesday.
Hey guys, it's Book Trader Tuesday, and today we're going to be reading The Raveness by Amy Lukovic. There's something wrong with Rose. From the outside, the